All right, today we're diving into something that's happening all around us, often completely unnoticed, a silent pandemic, one that could unravel the very fabric of modern medicine.
And listen to this quote. That's not from a sci-fi movie. That's a direct warning from a study by the National Institutes of Health. It's not hype. It's a very real, very sober assessment of where we could be headed.
And that's the thing that you have to get your head around. This is not some far-off, distant problem for our grandkids to solve. It's happening right now. The groundwork for this crisis is being laid today. So let's start by just trying to grasp the sheer scale of what experts are now calling a silent pandemic. Take a look at this number, 1.27 million. That's how many people died in a single year, 2019, directly because of bacterial resistance to antibiotics. To put that in perspective for you, that's more deaths than from HIV/AIDS or malaria in that same year. So what exactly are we talking about here? This thing called antimicrobial resistance, or AMR. It's pretty simple, really. It's evolution happening on hyperspeed. It's when germs, bacteria, viruses, you name it, they just learn to fight back against the drugs we made to kill them. And pretty soon, those drugs just stop working. And this is where it really hits home. AMR doesn't just make it harder to treat a bad infection. No, it puts the fundamental pillars of modern medicine at risk. All these procedures we completely take for granted, cancer treatments, organ transplants, even something as common as a C-section, they all depend on us being able to control infections. Without working antibiotics, all of these life-saving miracles become incredibly risky gambles. And if we just keep going down this road, the projections are, well, they're terrifying. By 2050, AMR could be responsible for 10 million deaths every single year. That would make it an even bigger killer than cancer is today. So how on earth did we get into this mess? To really understand that, we've got to rewind the clock a little bit, back to when this whole story began. Back in the 20th century, antibiotics were nothing short of a miracle. Seriously. They called them magic bullets because they could hunt down and destroy deadly bacteria with pinpoint accuracy. They completely changed the world, turning once fatal infections into minor inconveniences and saving millions upon millions of lives. And this timeline tells a really fascinating and kind of scary story. From the 40s to the 60s, we were in this golden age, finding new types of antibiotics all the time. But then, the well started to run dry. The last time we introduced a major new class of these drugs was way back in 1987. Since then, it's been a discovery void. We've basically been standing still while the bacteria have been evolving relentlessly. Which leads us to the really crucial question. How does a regular, everyday germ transform into one of these so-called superbugs? And superbug isn't just some catchy headline. It's a real term for these incredibly dangerous microbes that have figured out how to defeat not just one, but multiple drugs. You've probably heard of them, things like MRSA or drug-resistant TB. They're becoming a terrifyingly common problem in our hospitals and communities. At its core, it's all about survival of the fittest. It's natural selection playing out on a microscopic battlefield. Bacteria are constantly making little changes to their DNA. And when an antibiotic shows up, any bacteria that happens to have a random mutation that helps it survive, well, it lives. And then it multiplies, passing that winning gene onto all its kids. So how do they actually do it? Well, they have some pretty clever tricks. Think of a bacterium like a tiny fortress. First, it can beef up its walls to keep the drug from ever getting in. If some of the drug does get inside, the bacteria can change the target so the drug has nothing to attack. They can also create little enzymes that act like tiny weapons to neutralize the antibiotic. And if all else fails, they can literally install pumps to physically throw the drug back out. It's incredible. Okay, so if this is just a natural process, why is it suddenly a massive global crisis? Well, to put it bluntly, it's us. Our actions are pouring gasoline on this evolutionary fire. And it's not just one thing, it's a whole perfect storm of factors. We overuse and misuse antibiotics in people, giving them out for viruses where they do absolutely nothing. We pump tons of them into farm animals to make them grow faster. In many countries, you can just walk into a pharmacy and buy them without a prescription. Add in poor sanitation and not having the right tests to see what infection you actually have, and you've created the perfect breeding ground for superbugs.
And that brings us to the other half of this nightmare. Just as the germs are getting smarter and stronger, Our ability to fight back is getting weaker. As the World Health Organization says, the pipeline for new drugs to replace the old ones, it's pretty much dry.
This slide shows you the huge disconnect right here. The need for new antibiotics is absolutely critical, and it's getting worse every day. But the research and development from drug companies is lagging, and many have just given up entirely. The reason? Well, it's simple economics. It's way more profitable to create a drug for a chronic condition that someone has to take for life than it is to make an antibiotic that's taken for 10 days and cures the problem. It's a broken market. Now, I know this all sounds incredibly daunting, but it is not hopeless. There is a global plan to fight back, but it requires us to think about health in a whole new way. And that new way of thinking is called the One Health approach. And it's actually a really simple, brilliant idea. It just recognizes that the health of people, the health of animals, and the health of our environment are all connected. You can't solve drug resistance in a hospital if you're not also tackling it on farms and in our water systems. Everything has to be addressed together. So, the World Health Organization has basically laid out a 5-point battle plan. First, education. We all need to understand what's at stake. Second, we need better surveillance so we can track where these superbugs are popping up. Third, and this one's huge, we need to prevent infections in the first place through better hygiene and sanitation. Fourth, we have to be smarter about using the precious few drugs we have left. And finally, number 5, we've got to fix that broken market and create real incentives for companies to get back in the game of discovering new medicines. So at the end of the day, it all comes down to this question. Antibiotics were one of the greatest gifts of the 20th century. They made modern medicine possible. The challenge now, for all of us, is whether we're going to act to save it.